Hello and welcome to Algebra 2 tutorial. In this video we're going to continue looking at log and specifically log properties. So we just had an introduction to logs and how they work and how they are the inverse of exponentials, but I'm guessing we're still pretty iffy on what a log actually is and does and how to use them. So to get better at them we have to look at how math works with logarithms. And so to do that, we're going to look at the properties of logs. And so there's four of them that we're going to take a look at. Addition and multiplication go together, subtraction and division go together, and then there's a power and a base change property as well. So we got four distinct ones to look at. Each of them are pretty easy individually, but there's four of them, so that kind of makes it harder. So first, let's take a look at addition and multiplication and what that property looks like. So this property says that if you have two logs that are adding, so you can see the bases are the same, what you can do is you can take the insides and multiply them. So this will be log base 3 of 24. And so we can condense the two logs into one. As long as the logs are the same base and they're adding, we can multiply the insides. So here's it is with just letters, so you can see how it works. You have one log of A plus another log B. What you can do is condense it into one log and then multiply A and B together. So now why does addition go with multiplication here? Well, we have some precedent for that. So let's go back to exponents. If I have x to the third times x to the fifth, so our bases are the same again. What can we do with the exponents? Well, we add them, x to the 8th. And so we already have this connection between multiplication and addition when we're talking about exponents. And a log is the inverse of an exponential, so hopefully it makes sense that they would be related. So if we have adding between two logs, we can multiply the insides. So that's the general rule. Let's take a look at how we can apply that. So here I've got two logs that are given. Log base 6 of 25 is 1.79, and log base 6 of 4 is 0.77. So we're going to use those two logs that we know to figure out some logs that we don't know. So our first one, log base 6 of 100, what I'm going to do is rewrite this. So 100 is the same as 25 times 4. So I don't know anything about the 100, but I do know a lot about the 25 and the 4. So now I'm going to separate this log. I'm using the property backwards, and so this can be log base 6 of 25 plus log base 6 of 4. And now because I know something about these two, it was given, I can write this as 1.79 plus 0.77. And then add those two together. We have a 6, carry the 1, 14, 15, carry the 1, and 2.56 it looks like. All right, so I'm going to do the same thing with this one. I've got the 16, which I don't know anything about, so I have to turn the 16 into some numbers that I do know something about. And so I'm going to break up this 16 into a 4 times a 4. I can now take this log and break it up into two logs that are now adding. So again, we're using the property, but we're kind of doing it backwards. And now I know something about these two. The first one is 0.77, and the second one is also 0.77. And so we add those, 4, 1, 5, 1.54 it looks like. So using two logs that we know something about, we can use them with this property to find some logs that we didn't know anything about. But that's just one way how you can use that property. All right, that's our first one. Now it's on to subtraction and division. So this one is actually very, very similar. If I have two logs that are subtracting, you can see they have the same base again. What we can do is divide the inside. So this will be log base 7 of 6 divided by 2, which is log base 7 of 3. So again, hopefully this might make a little bit more sense since addition and multiplication were together, that subtraction and division are together. To show you another reason why, we can go back to exponents. If I have x to the 5th over x cubed, so if we're dividing two bases that are the same, what can we do with the exponents? Subtract them. X squared. And so we have this connection between division and subtraction, and we're just doing that same thing but sort of backwards. And here's the property again with letters. You might want to take a look at that. Again, if you have log of A minus log of B, you can condense that into one log where you divide A and B. All right, let's use that in some numerical examples here. So here again are two logs that we know, log base 3 of 24 and log base 3 of 4. So using the 24 and the 4 that we know something about, I need to figure out something about this 6. So we're going to rewrite it. So the 6 can come from 24 divided by 4. So now I've got this division problem, which we can break up into a subtraction problem. So log base 3 of 24 minus log base 3 of 4. So again, I'm applying this log property, but I'm kind of doing it backwards. And so now this one is 2.89 minus 1.26. So 9 minus 6 is 3, 8 minus 2 is 6.1. There we go. All right, one more. This one's a little bit more tricky. We got to get a little fancy here. So how can I turn this 2/3 into numbers that I actually know? Into a 24 or a 4? Well, 2/3 is actually 4 over 6. That fraction reduces down to 2/3. And so I can turn this into a subtraction problem. Log base 3 of 4 minus log base 3 of 6. And this one we know something about. That was given, 1.26 minus, and this one we just found out actually. This was our previous problem, so that is 1.63. So there we found something about that one, and I'm not going to do that one in my head, I suppose. So 1.26 minus 1.63 is negative 0.37. There we go. All right, so again, we're just either condensing or expanding these logs, trying to find a pattern. So that's our second property. So our next one is the power property. What if we throw in some exponents? So we've got log base 5 of 2 to the 4th. So what this says is you can take that log base 5 of 2 and then take this 4 and bring it out. It comes down in front. And that is just an extension of the addition multiplication property, because this is log base 5 of 2 times 2 times 2 times 2, 4 of them, right? Well, I can turn that into log, that is not how you're going to write log. Log base 5 of 2 plus another log base 5 of 2. I'm going to have 4 of those, 1, 2, 3, 4. And if they're adding, you can combine them all and have 4 of them total. of log base 5 of 2 is sort of that. So to do it with letters, if we have any log, and on the inside we have x to the n, I'll use those letters. What we can do is we can take that n and pull it out in front, just like that. So this one's one of the easier ones. We're not going to do too much of these, but I do want you to just see this. So the 7 we can bring down in front. So 7 log base 3 of 6. All right, so here we're going to do a little bit more fancy stuff here. Log base 4. And 256. 256 is 4 to the 4th power. So we can take this 4, bring it out to the front. And if you remember, log base 4 of 4, that cancels itself out because we ask ourselves 4 to the what power is equal to 4? Well, that's equal to 1. And so this whole thing is just equal to 1, and we can actually simplify this one a lot, down to 4. So that's one of the easier ones, the power property. You can take an exponent on the inside and bring it down to the front. It can be really useful when you're trying to simplify things. All right, one more, and it's probably the most important for us, the base change property. So you probably realized that, hey, we got lots of decimals, exponents, this is hard. Couldn't we do this on a calculator somehow? And the answer is yes and no. There is a log on the calculator, but it's oftentimes not the log you have in your problems. There is no log base 6 on your calculator. The only thing on the calculator is log base 10. That button does exist. So we need a way to take a log base 6 and turn it into a log base 10. And the way you do that I have right here. What you do is you take the log of 50 on top, and this will be base 10. It could technically be any base you want it to be, but because 10 is on the calculator, that's the one you're usually going to choose. And then that's divided by log base 10 of the old base. And so this will give us what we want. And so we can just type that into the calculator, and we can actually determine what that is. So let's turn this on. All right, so we want log, it's right here, of 50, close the parenthesis, divided by log of 6. So now these are both log 10s, log base 10, but this base change property allows us to figure it out. So it's 2.18, it looks like. 2.18. All right, one more here. So this time I have log base 8 of 75. I can't type that into the calculator the way it is, so I have to rewrite it. So on the top, you take the 75, and on the bottom, you take the 8, the old base. And this will give us log base 8 of 75. So let's type that into the calculator. Log 75 divided by log 8. So 2.07 it looks like. All right, that is our last property we've got. We've done all 4 of them. So let's take a quick recap of everything we've got. So the 4 properties. So what you have to remember is that addition and multiplication go together. Subtraction and division go together. If you have an exponent, you can bring it down to the front. And if you want to type something into the calculator, it takes a division problem. You do the log of the number you want on top divided by the log of the old base. And that makes you do everything on the calculator that you need to. All right, let me give you a few practice problems to try out. See if you can do all of those, and if you can, you're doing pretty good. Good luck.